Another common application with trigonometry is in sailing and in the term called bearings. So the bearing from point O to point P is the acute angle measured in degrees. So again, here's another application typically in degrees between the ray OP and a north-south line. And I have some examples to show you because I think it'll make a little bit more sense once I do. So here are a couple different angles. Notice that instead of using X's and Y's on our axes, we're doing north, south, east, and west. So N is for north, S for south, E east, W for west. And let's say you have an angle coming out here with a point P. Now your bearing is always in reference to a north-south line. So to that kind of Y-axis, not necessarily to the east axis. So your angle is always taken off the Y-axis. So here, the angle from that line or that ray to the north line here is 40 degrees. Now, that's where you see the 40 degrees from. Now, the end into play as well here because the angle is taken off the north part of the line. And if you look at that ray P, it's heading towards the east side of the graph. So we write that as north, 40 degrees east. Here, you have another ray coming out this time into the second quadrant. Again, that degree is always taken off of the north-south line, never on the east-west. So to the north line, this is be a 65-degree angle from the north line to the OP ray. It's north 65 degrees again because it's taken off the north part of the line. And then the angle though is heading towards the west, right? So we write north 65 degrees west. And here's one example using the south side of the line. So here you're off into the fourth quadrant here. And again, it's myself too, I always want to go with just the closest axis, but it's always the north-south line. That's how you determine the angle. So here your angle is compared to on the south side here, and it should always be an acute angle. So there would be 70 degrees in between the south axis here and then the OP ray. And again, it's on the south side, so we write south 70 degrees, and then the angle is going towards the east side. So south 70 degrees east. So let's do one example here. And what we're going to do in each case is we're going to find the bearing. So for A, we're going to find the bearing from O to B, and O is your origin, right? So it's at center, that intersection here. And then we're also going to find the bearing from O, oops, sorry, or A. We're doing B and C here, to C. All right, so you have the angle set up for you, so you don't have to find the angles, but we do have to write the notation correctly. So for the first one, I try to use different colors to make it a little bit easier to see. And you want to remember that your angle is always off of the north-south line. So if I focus just on this first ray here from O to OB, then the closest angle is through the north line, right? And I can see that that angle between the north line and the ray is 40 degrees. So I write north 40 degrees. And if I look, that ray is going towards the left side of the graph, right? That would be the west side. So I write this as north 40 degrees west. Now we're going to do OC. And here we know that the angle between the east-west axis and our ray is 75 degrees. You do want to be careful though, because when we're talking about bearings, it's always off the north-south line. So I actually don't care that this is 75 degrees. I need to find this angle here. Right? This is actually the angle that I need instead. Always off the north-south line. So if you think about this quadrant here, that quadrant would have 90 degrees in it, right? It's a perfect right angle. So, 90 degrees minus that 75 leaves you with 15 degrees left over. So the angle we're looking for is actually the 15-degree angle because it's off, again, that north-south line. So it's going to be south, because we're off the south side, 15 degrees. And again, this one happens to also be on the west side. So we will write west. All right, now let's do an example. And for this one, I think it may be easier just to talk through. So I'm going to make a little note here. All right, so we're going to do example 6 on page 640 in the pre-calculus book. And I'm going to bring up the book for a second. I'm just going to talk it out. But I do encourage you to take notes off to the side, either in your own notebook or in your text, whatever is easier for you. But the picture is really helpful here, and it's going to be a little hard to recreate. So I'm going to bring in the book. All right, so let me scooch that. All right, so I think we can get most of it in here. And again, if you want to pause this and copy this into your notes, now is a great time, and just take your time with copying the picture so that you fully understand it. So we're going to have a boat. Again, I said that there's a lot of applications in boating as well with Trig, and boat building, and also in directions. So a boat leaves the entrance to a harbor and travels 25 miles on a bearing of north 42 degrees east. So in our picture, you can see our harbor is going to be right here. And remember, when we're talking about bearings, it's always off a north-south line. So the book gave you what the north-south line would look like here. And we're traveling 42 degrees and towards the east. So you're going towards like a right side of the graph. So you can see there's that 42-degree angle. And we're going towards the east. So you're going towards the right side of the graph, not the left. And then we're going to travel 25 miles. So this first piece right here, from here to here, okay, is this first sentence. All right, so now what happens is, obviously you're not going to go straight forever. You're going to turn the boat, right? So the captain turns the boat at night, and that's this piece right here, and then travels 18 miles. Okay. And that is on a bearing of south 48 degrees east. Okay, so again, that's always off a north-south line. So you're starting where that turn was made, and now we're going in this direction. So we're going 48 degrees off that north-south line. South meaning that you're going downward here. It's a little hard because you don't have that cross axis, but because we're going in a downward direction, that would be south, upward would be north. So we're traveling south now, going downward, and again, east. So you're going down towards the right rather than down towards the left. And that's that next part that you read here. Okay, so that's your second sentence. So now what happens is your boat is way over here and the harbor is here. Okay, so this is how far you are from the harbor. And that's our question. So how far is the boat to the nearest of the mile from the harbor entrance? So this is what we're trying to find now, this piece. And if you think about this, I know the length of the other two sides. One is 25, one is 18. I can use a Pythagorean theorem here. And that's what your book has, and they do that. So this is your hypotenuse is the C. So we do 25 squared plus 18 squared, which is 949. And then don't forget, you do need to take the square root to solve. And again, the positive square root here, because we're doing, something with a length, you can't have negative length. And it's going to be about 30.8 miles. So the boat is about 30.8 miles from the harbor. Okay. The second question here is, what is the bearing to the nearest tenth of a degree of the boat from the harbor entrance? So remember here, when we're talking about bearings, it's always off that north-south line. And what you're looking at here, I'm writing in my book, but it's easier so you can see, I'm looking really for this angle, this whole thing. That's really what I need here, right? Because if I make kind of like my axis going straight here, I would need this whole angle from this part of the line to get that bearing. Now I have part of it, I have the 42 degrees, but I don't have the missing theta piece. So theta is not the final answer, it's only part of it. The theta plus the 42 is the entire angle that I need here. And that's the next part that they use here. So let me switch down a little bit so you can see how the solution is set up. And what they're going to use here is they're going to use tangent of theta. So we're going to use that little theta. That's kind of the piece that we have to find. So if I can put it with the 42, then I know that whole angle. So if I think about my tangent here, tangent would be opposite over adjacent. Remember, C would be your hypotenuse. There's nothing wrong with using something else like sine or cosine here. You'll notice that usually we like to use the original angles and values the most rather than the ones that have been computed. So we're going to use tangent here, and tangent of theta would be opposite over adjacent, so 18 over 25. Now you can't solve, you don't know the theta, so to solve here you have to use the inverse tangent. So I can do inverse tangent of 18 over 25, and we do use our calculator. And when you do that, you get that 35.8 degrees. Now don't forget that 35.8 degrees is just the theta. I need to add that with the 42 to get the entire angle there. So that's what they did next. They added that with the 42, and we actually got the angle was 77.8 degrees. Now, this angle was created off the north part, right? Because we're kind of going upward here rather than downward. I can't go downward here because my angle would not be acute. It'd be too big. So your angles have to be less than 90 degrees. So I have to go northward here. But again, it's on the right side of the graph, so that's in the east direction. So you have that final answer of north 77.8 degrees east.